Hey guys, so here are the notes for 1.4. We were once going to again solve quadratic equations and factor quadratic expressions by factoring, but this time we're going to do it when a is something other than 1. Okay, let's look at this first one. We're going to factor 5x squared minus 17x plus 6. Now, how we're going to go ahead and factor these quadratics is what we call the guess and check method. So you guys should kind of be familiar with that. Whenever you don't know how to do something, that's kind of your last resort. We're going to do that here. So just like we factored when a did equal 1, we figured out what are the numbers that multiply to our last term, the c value or the constant. We're still going to do that. So we're going to have 1 and 6 and 2 and 3. Now the other thing though is we are also going to find the factors of our first term, the a value. So here we have 1 and 5. So now we're going to create our two sets of parentheses, kind of leave some room, and you might want to use a pencil for this because you might be doing some erasing. So notice the 5 only has one pair, so we have to use it. So I'm going to have 1x and 5x. Now for the 1x, you could just put it as x. It's really up to you, or 1x, that works as well. Now notice the 6 though, we have a couple of pairs here. So what we're going to do is actually start from the bottom of our list and work our way up. So I'm going to put 2 here and 3. So we're going to multiply the inner, so we get 10x, and then multiply the outer, and we get 13x. Now the thing is, we are trying to add up to our middle term of 17. So we look at 10 and 13, 10 and 3, not 13, but 3. Will 10 and 3 ever work? No. So having the 2 in the first parentheses and 3 in the second does not work. So what we need to do next is we're going to erase the 2 and 3 and just switch. So instead of saying, oh, 2 and 3 doesn't work, we have to actually switch them. So I'm going to put 3 in front and now 2 in the back. So now multiply the inner, we get 15x, and multiply the outer, we get 2x. And if we add or subtracted these, yes, we get negative 17. In order to get negative, both of these need to be negative as well. So I have this. So I'm going to go ahead and write this out so it looks a little bit nicer. So my final answer here is going to be x minus 3 times 5x minus 2. And that'll be my final factorization here. Okay, let's go ahead and do the next one. I would like you guys to go ahead and try this one on your own, so pause the video to do so. Okay, let's see what you got here. So once again, find the numbers of your constant. We have 1 and 7. And for your a term, also find numbers that multiply 1 and 3. Now these are nice and easy because we have to use those numbers since they are the only ones in the list. So 1 and 3 we have to use. It's all just kind of depends on what is the way we can fit them. And then let's try 1 and 7. So I multiply the inner, I get 3x. And I multiply the outer to give me 7x. So if I look 3x and 7x, if I added or subtracted, would I ever get 20? Nah. So that means I need to switch my 1 and my 7. So let's put 7 in the front and 1 in the back. So I do 7 times 3x to give me 21x, and then x times 1 just to give me x. So if I added 21x and x, or added or subtracted, could I get a 20? Yes. Now notice I have a positive 20, so I need my x to be a subtraction. So I'm going to have 3x minus 1 and x plus 7. So I'm going to just rewrite this so it looks a little bit better. So I actually have x plus 7 and 3x minus 1. Oops, that should be a minus. There we go. Okay. Let's continue to factor when a does not equal 1. Okay, so remember when we talked about when a did equal 1 and we talked about the two special types of factoring? We had our difference of squares or difference of two squares and then the perfect square trinomial. Well, we're going to also have that now when a does not equal 1. Let's look at the first one. We have 9x squared minus 64. So remember, in order to be a difference of two squares, it needs to be a binomial. Okay, this is checked. It has to have subtraction, check, and the a and the last term have to be perfect squares. Both 9 and 64 are. So this is what we call a difference of squares. Or a difference of two squares, whatever you would like to call it, okay? So how we're going to factor this is similar to what we did when a did equal 1. So we create our two sets of parentheses. For a, we do take the square root of it. So what's the square root of 9? It's going to be 3, and we have to have x's with those. And what's the square root of 64? That's going to be 8. So remember, when we do a difference of two squares or a difference of squares, one has to be a minus and one has to be a plus. And order doesn't matter, so you could have 3x plus 8 and 3x minus 8. Okay, let's look at our next one. So notice here, for our b, we have a trinomial. We have two pluses. And notice that the a and the last term are perfect squares. So this is actually what we call the perfect square trinomial. Okay. So how we're going to do this one is, once again, we do our two sets of parentheses. Boom, boom. For a value, just like we did here, we're going to take the square root of that. So we have 2x and 2x. The square root of 4 is 2. Now we're going to take the square root of 25, and that's going to be 5. Now, notice we have a plus in front of our middle term. So that means both of these have to have plus. And remember, there are two ways of writing this. You could have 2x plus 5, 2x plus 5, or because they are exactly the same factor, we can write 2x plus 5 and then just square. Okay, let's go ahead and do the next one. So we're going to continue to factor, and we have multiple ones here. So these are going to be where can we take something out. So sometimes when a does not equal 1, it is possible that there is a common factor that all terms have in common that we can actually take out first and then continue to factor. So let's look at a. We have 5x squared minus 45. Well, let's look at these two factors. Now, when we think of common factors, that can either be a number or a variable or both. So let's see if these two terms have a number in common. Yes, they have a 5 in common, so I'm going to go ahead and take that out. Do both of these have a variable in common? No, because the first term has a variable, but the second term does not. So I just take a 5 out, and what I'm going to do is actually rewrite this expression. So I do 5 divided by 5, that gives me 1, and so I'm left with x squared. And then I do minus, and then 45 divided by 5 gives me 9. So now I factor what's inside the parentheses, and I can do that because I still have a squared. So I'm going to bring down the 5 and create two sets of parentheses. Okay, so notice what this is. We have a binomial, we are subtracting, and our a and our last term are perfect squares. This is a difference of squares. So we should have x and x, and then what's the square root of 9? That's going to be 3. And know that one has to be minus, one has to be addition. So this would be our final factorization. Okay, let's go ahead and try that for our next one. So we're going to see if these three terms have anything in common that we can take out. Well, let's think of a number, 6, 14, and 8. Is there a number that these three have in common? Yes, it's going to be a 2. What about a variable? No, because the last term does not have a variable. So we're going to take a 2 out and rewrite this expression. So I do 6 divided by 2, that gives me 3q squared. And then negative 14 divided by 2 gives me minus 7, then I have a q. And 8 divided by 2 gives me plus 4. So now this is kind of just factoring like we did in the previous examples. So what I would like you to do is go ahead and pause the video and factor 3q squared minus 7q plus 4. Okay, let's see what you did. So don't forget, make sure if you have anything in front of the parentheses, make sure you keep bringing that down. We create two sets of parentheses here, and we need to figure out what numbers, and first multiply to 4. So we have 1 and 4, 2 and 2. And for the 3, we just have 1 and 3. So that one's nice because we have to use that. So I have x and I have 3x. Now, when you have multiple pairs in your list, start from the bottom because usually that one will work. So I'm going to use 2 and 2. And what we're doing is we're trying to add up to a negative 7q this time. And the reason being is that we took this 2 out. Okay, so I do 2 times 3x, that gives me 6. And then I do x times 2 to give me 2x. Now, if I have 6x and 2x, will that ever add up to our q? Which really I should be using q and not x, because that's the variable we have. And to answer that question, no. We can't add or subtract 6q and 2q to give us 7q, so that doesn't work. Okay, so now, no, if we switch the 2 and 2, we get the same multiplication. So we automatically know the 2 doesn't work, so I can slash that out. So now we need to try 1 and 4 and make sure we're using the correct form there. Okay, so let's put 4 in the back, and then we have 1. So let's do 1 and 4. So we do 1 times 3q, that gives us 3q. We do q times 4, that gives us 4q. So we have 3q and 4q. And we add or subtract. Would that add up or subtract to negative 7? Yes. They both need to be negative. So we have q minus 1 and 3q minus 4. So our final factorization here is going to be 2 times q minus 1 times 3q minus 4. Okay, go ahead and pause the video and try C for me, please. Okay, let's see about this one. So, once again, we need to see if these two terms have anything in common. Okay, first of all, let's think about a number. Do these two have a number in common? Yeah, a 5. So we're going to take that out. Do they have a variable? Yes, they both have a z. So the most I can take out is just one z because that's the most that the last term has. So now let's go ahead and rewrite this expression. So I do negative 5 divided by 5. That gives me a negative. And then if I take a z out of the z squared, that leaves me just z. Then I do 20 divided by 5, and that gives me 4. And when I take a z out of a z, I'm not left with anything. Now, usually we say, okay, now let's factor the expression again. However, notice that this negative z, it does not have a square with it. Since it doesn't have a squared, we actually cannot factor anymore. So that 5z times negative z plus 4 is our final answer, okay? Now, there is actually another way to factor this. If you wanted to, you could actually take a negative 5z out, and for that, your final answer would be z minus 4. So both ways are correct for your final answer if you want to do that. Okay, let's try D. Go ahead, pause the video, and try that on your own. Okay, let's see what you guys got. So first of all, do these three terms have something in common we can take out? Yes, they have a 3. What about a variable? No, because the last term doesn't. So now I'm going to rewrite the expression. I do 12 divided by 3 to give me 4. And then 21 divided by 3 gives me 7. And that's a negative, so I get negative 7p. And 3 divided by 3 gives me 1. Okay, now let's see if we can factor this. So don't forget, bring your 3 down. We do our 2 sets of parentheses. Nice part is 1. The only numbers that multiply to it is 1 and 1. And then for 4, that's going to be 1 and 4 and 2 and 2. So there will be probably 3 ways we can see if this works. Okay, so I know I have to have 1 and 1 because that's the only pair I have for that. Let's try 2p and 2p and see what we get. Okay, if we multiply the inner, 1 times 2p gives me, of course, 2p. And 2p times 1, there you go. Now remember, we're trying to add or subtract to the middle term of this case of negative 7. Well, this doesn't work, so let's go ahead, let's change, and let's do 1 and 4. So I'm going to have just a p here, and then I'm going to have a 4p. So the middle, when I do 1 times 4p, gives me 4p. And p times 1 gives me p. If I add or subtract, can I get a negative 7? No. Now here's the thing, if we switched it, because our 1 and 1s are exactly the same, right? When we just get the same answer, yeah. So that means we couldn't actually factor the 4p squared minus 7p plus 1 anymore. So this would be our final answer, 3 times 4p squared minus 7p plus 1. Okay, make sure you watch the other videos over 1.4. Next, we're going to be solving, and then we're going to be doing a word problem. Okay, see you guys later.